What's going on, everybody? Welcome to the Data Dive from AWS OnAir. You might be thinking, who's this shockingly good-looking guy that's hosting for the first time on this show? Well, my name's Nick. Usually I'm backstage or hosting the AWS OnAir sports show, but the Data Dive team has graciously allowed me to guest host their show today because we've got an awesome special guest when Eric Peters from the NFL. Eric, can you give us a brief introduction into who you are?
Hey, Nick. I am the director of media administration and post production here at NFL Media. And we are located in Inglewood, California. And we sort of, we're making all the content for all the great NFL properties that everybody loves to check out.
Awesome. And I know I'm super excited to get into this, guys. We've got a great demo for you today talking about the new tool, data retrieval tool that the NFL has come up with to help with media broadcasting, finding clips, putting together social content, anything visual that you see related to the NFL. It's super awesome. Eric's been behind the whole thing. He can show us some cool demos today. But Eric, before we get into the interview, we got some housekeeping first, you know? First and foremost, we're going to be on the US Twitch homepage today. We're going to be having some new viewers. So welcome everybody. If you've not seen this show before, again, this is AWS On Air, The Data Dive. We air every Thursday at 10 a.m. Pacific time to talk about the latest things related to databases in the cloud. Lots of cool lots of cool hands-on demos, talking through use cases, talking through the tech, looking under the hood of all these awesome things that are happening in the world of databases and the cloud. I am guest hosting for this first half of this episode related to the NFL and their new data retrieval tool. Now, guys, we've got a survey as you're watching today. We're going to be talking, I don't know about y'all, but I definitely miss the days when I could take standardized tests. I long for the days of Scantron. So I'm always happy when I get just three multiple choice answers. By multiple choice, I mean rank us on a scale of 1 to 5 on just three questions. You get $20 in AWS credits for the first 200 people to reply to the survey. I'll keep pumping that as we go throughout the segment today, but just want to say that at the front end. As you go today, if you like our show, you don't like our show, give us your opinion in that survey. But it should be a great show for us today. So I know it looks like most of our audience is here, so we can go ahead and get rolling. Eric, you said you work in the media for the NFL. Can you give us a little bit more of an insight into what exactly you do day to day for the league?
Sure. So, I am a man of many hats, I would say. I am in charge of our asset management system. I'm also working on lots of different AI projects that we have going, and also just sort of making sure that all the footage that all of our editors, content creators, producers, production assistants, anyone who would need to see footage within our building, so that they can create the content that gets out to the fans. Just making sure that that stuff is available to them and trying to get it to them as quickly as possible.
Gotcha. And you're telling me you kind of work with all the different various medias related to the NFL. So we're talking NFL Network, the NFL social media teams, maybe clips you see on other sports shows or online on YouTube. Is that accurate?
Yeah, I mean, everything from the network to NFL Plus to Red Zone, social media, we've got a fast channel, YouTube, you name it, we've got it. So,
Gotcha. So you're kind of like the middleman between all of these different clips that come in every Sunday, Monday, Thursday, sometimes Saturday, and what we see on all these highlight shows and other programs in the NFL.
yep. And at this point we have over 1 million assets that we're
Wow.
tracking in our asset management system. So it's a very large library of content that people have to pull from, and it's growing every day.
Gotcha. Now, the other thing is, as fans come in today, definitely drop your favorite team in the comments. Don't forget, Eric works for the NFL. So go ahead and trash talk in the comments a little bit about your favorite team. Let us know who your favorite team is. Eric, do you have any? I mean, obviously, we're fans equally of all teams here. But did you have a team you grew up rooting for in the NFL?
I was always a Buccaneers fan growing up. I grew up in the Mike Allstott days.
Oh, jeez.
So I love the stories of him from when he was in high school. Pushing pickup trucks between telephone poles, that sort of thing.
Gotcha. So you're looking forward to tonight's game with the Bucks and the Falcons coming up, yeah?
Oh yeah, and the Falcons, even though it's a division rival, there's special place in my heart for the Falcons because Warwick Dunn was a great Buck for a long time, and then he moved over to the Falcons. And I when I was younger, I always followed the Falcons a little bit because of Tim Dwight, because he went to my
Okay.
high school, and he was just such a an impressive kick returner.
Definitely. I mean, it's going to be a great game tonight. I can't wait to see Captain Kirk versus Baker. Two pretty cool comeback stories, honestly. It also makes me a little bit salty. I'm a fan of clinical depression, actually, aka the Denver Broncos. And very, kind of rubbing salt in an open wound how you guys just went right from Tom Brady to Baker Mayfield. We didn't have as great of a transition from Peyton Manning. So
Yeah, it's been a
hoping
little rough.
hoping that Nick's can help us here. Looks like we got a fan shouting out the Bucks too. Let us know who you guys think's gonna win tonight, or your favorite team. Hopefully, some other Broncos fans out there. I know we don't like to publicize it in these dark years, but let us know your favorite team as we go throughout the show here. We might be able to pull in some fun clips for your team during the demo here in about 15 minutes. So be sure to let us know your favorite players, favorite teams. So, Eric, I mean, you're basically, like we said, the middleman between all these clips that come in from all the games and what we see on TV as fans. That's kind of my dream job as a kid, frankly, just being able to watch football all day and put together these highlight reels.
Yeah.
I know something that we have a lot of feedback from our fans, especially our younger fans here on Twitch, is to figure out how exactly these jobs came to be, maybe how you got there, any tips you might have for them as they're starting their career, because this is, frankly, the dream job for a lot of our viewers here. So, how did you get into the position that you're in today?
I came from a reality TV background actually. And so I took maybe a strange path compared to what most people do coming into the league.
Gotcha. Yeah, I feel like that's everybody, right?
Yeah.
It seems like there's never point A to point B. There's always a bunch of random stops in the middle, and then you find yourself in the job that you love, right?
Yep.
Awesome. So let's get into this a little bit. So I know AWS and the NFL have been partners for a long time. I know we actually just re-signed that relationship, made sure there is an extension that we're going to be partners for a long time. I know that we've done a lot of projects together. We're both very on the same page about trying to push the envelope for technology and making sure the NFL stays as cutting edge as possible. So I know a lot of fans out there, including myself before I joined AWS, knew the partnership from StatThat and like next gen stats and all that. Can you give us some background though? How did this partnership between AWS get started? Maybe when, and what are some of the other projects that we've worked on leading up to what we're be talking about today?
Yeah, I mean, the partnership between AWS and the NFL has been a really great one. A lot of great innovation has come out of it. I think sort of starting with next gen stats, and then we've done a lot of work in player health and safety. My group specifically has been utilizing AI tools within AWS for 5, 6 years now, in various capacities. And with this project, we started looking at how can we take all the stuff that we're already doing with AWS, and how can we turn that into a generative AI project.
Gotcha. So let's talk a little bit about kind of your team specific use case. Let's start with the background. You said you have over 1 million assets that you're tracking, right?
Yep.
So can you tell us a bit more about what is the data that you are collecting or the clips that you're collecting that goes into those 1 million data points to give our user or our viewers a little bit of a context into what we're going to be talking about today?
Sure. So, I mean, ultimately, we get media constantly throughout the week. So, let's if we start on Sunday, on Sundays we're recording all the games that are happening. We generally record two different versions of the game. We have a version that has graphics like you would see on TV at home, and then we have another version that has no graphics on it at all. So it's just clean video. Um, We also then are getting footage from NFL Films, who's shooting all that wonderful 24 frame film look
Mhm.
footage uh, at every game each week. We're getting social media content from our LCCs that are on the field shooting with their phones maybe. We're getting what are called broadcast melts after the game, which is every single angle of every play within the game. So we're getting footage from a wide variety of sources. Press conferences. If a team goes out and does like a community event, we're getting footage in from that also. So
Yeah, and I think that's a cool point to address first and foremost here is that I feel like a lot of fans, we know maybe the end zone angle from the field goal post, we know the typical broadcast angle from the side. You guys are getting multiple feeds from multiple different sources, all with their own unique camera angles. So we're talking about maybe like the pylon cams, the normal broadcast angles, the replay, the NFL films, the social media. It's not even just the clips from the standard broadcast, it's from three, four other sources for each of these games, too.
yep, exactly. And some fans will be familiar with the all 22 coaches angle, which you can access through NFL Plus. But also, if you're watching, say, game day morning on Sunday morning on NFL Network, then maybe you're watching Kurt Warner do a Warner's Corner, and he's diagramming a play. So all these different angles go into a lot of the different types of footage that we compile then into the pieces that show up on our properties that everybody loves to watch.
Gotcha. So that kind of gives us an idea of all the different. I mean, you imagine one play, basically 25 different camera angles, all the different plays that happen every game, every weekend. That's obviously a lot of stuff you guys have to go through.
Yep.
So when you have in the past been putting together these clips for NFL Network or your social media, or, how did your team operate, last year with having to sort through all of these millions and millions of camera angles?
Sure. So, because we have next gen stats that we can leverage, there's some really great next gen stats tools that are available to our internal teams that they can use for research. Uh, but generally what they're doing is they are going through and they're selecting a bunch of filter options, and they're setting up a search, they're doing a search, they get back, say, you know 20 plays as a result, and then for each of those plays, those plays are identifiable by a combination of a game key and a play ID. So each game gets assigned this game key, and then each play is assigned a play ID. So they can then take the game key and the play ID and go into our asset management system and do a lookup of that specific play, one play at a time, and find all the video footage that we have of that one specific play. And then they would go back to that list of results, and they would do that search over again in the asset management system, and then they would go back and do it over again, back, do it over again. So you can see how that can kind of become a long process. And when we're working in a live TV environment, like we are in our building, sometimes you don't have the time to you know spend all that time going back and forth.
Yeah, I mean, you basically each one has its own barcode. That's
Yeah.
that's crazy. Y'all would have to kind of manually search through all these barcodes to. Frankly, it's amazing to me that you were able to put together clips and highlight reels for all these different shows. So, I mean, obviously, the need for something to make that a little bit easier is pretty self-explanatory. But what was kind of the aha moment when y'all realized, like, hey, let's really put our foot down and try to get something done to automate this process a little bit?
Right. Yeah, I mean, obviously generative AI has become a big thing in the last couple of years. And maybe a year ago we started thinking about, well, how could we leverage Gen AI to maybe let users have a little bit easier experience of, instead of having to figure out all of those filters that they need to click, click, click. Oh, I did one wrong. So now I have to uncheck it and start over maybe.
Yeah.
Um, how can we make it so that they can just say, hey, show me all the Josh Allen touchdowns in 2023.
Yeah.
And I think it's as we'll see in a little bit, it really worked out pretty well.
Yeah, and it's cool, talking to the NFL for the last couple of years as we've been doing these shows. The use cases for y'all, I think, are the most kind of easy to visualize, right? I know we had Mike North on last year from the scheduling department talking about, I mean, making the schedule used to be you had two whiteboards and you guys would basically be able to create two schedules over the course of like 6 months. Now they create two schedules every day, right? And you're able to pick the best one and account for more things. It sounds like that's what your team was driving towards here too, right? Went from a manual process where you have these kind of barcodes, you're manually searching for these clips, and you want a tool that's just, hey, plain English. I'd love to see, when Lamar threw a touchdown on fourth down and make it way easier on everybody. It gives you guys, I'm sure, a lot more flexibility, a lot more kind of ability to do different things for these shows and give some better quality content too, right?
Yeah, and I think, ultimately it allows our content creators to spend more time in the creative space, right? Like you're spending less of that time doing your research, less of the time um, doing sort of that administrative front end that you have to do in order to get to the place where you can decide which clips you want to use.
Yeah.
And now you're, very quickly getting to the, okay, now I have all the clips at my fingertips. Let me really dive in and start putting my piece together.
Yeah, and my last question here before I want, our audience to be able to see this tool in action. So we came together, you called us at AWS, you said, "Hey, let's try to get this tool built, Gen AI, all that, ride the wave, all that fun stuff." Uh, can you tell us like what's been the time difference maybe? So like for a typical producer editor for you guys, you got a typical week of here's all my game footage, old process versus new. What's changed exactly?
Yeah, I mean, I would say that, you went from this process where it would take maybe 2 minutes to, really dial in the search that you were doing. And then at that point, like if you had, say, 20 plays, it probably
Mhm.
took you about 10 minutes to do the individual searches for each of those plays and, maybe do like a quick scrub through some of that footage. Now we're to a point where you ask a question, it comes back in 30 to 45 seconds with a list of plays. And at your fingertips, you have links that'll take you directly to all of that footage without having to do any of that manual lookup of play IDs anymore.
Yeah, it's crazy. To me, it's always really cool to hear the time transition. How we went from all this time spent maybe on a clip previously to 30 to 45 seconds. I think that's
Yeah.
really cool. Let's get into the demo here. And while we're pulling that up, you got a shout out in the chat here, Eric. Phil Murray says that you have a pretty epic beard, and I think I agree. It's pretty darn good. Another one said Eric's got such a cool job here. That's pretty sweet. We got some other people coming in telling us their favorite teams and also telling us they would love. We got a fan looks like Gallo J of I think the All 22 film. So let's get into some of these clips, show them how it works. So
Yeah, let's do it.
can we zoom in a little bit? Looks like it's a little bit small for some of our viewers.
Yeah, sure.
There we go. So let's start with an easy one. So this is the tool that you guys use now, right, to go through all these clips.
Yep, this is what we've been using since the beginning of the season now.
Gotcha. So I know it looks like uh, we talked about Lamar throwing touchdown passes and stuff. Let's start maybe with him. I feel like that'd be a good use case. So we
Sure.
do Lamar Jackson rushes on third or fourth down in the fourth quarter. I feel like every time he plays our team, he kills us with that. So should have ample footage.
All right, let's give it a shot.
And while it's loading, guys, if you've got any ideas for things you want us to run in this system, maybe for your favorite team or favorite player, drop them in the chat. We'll see if we can input some stuff from the fans here, from the audience.
Yeah, so this is actually a really good example because not everybody might know this, but Lamar Jackson, there's not just one Lamar Jackson in the league. There's
Oh,
two. So the way that our chatbot works here is it actually is going to, if it doesn't have enough context to understand that, Lamar Jackson is the Baltimore quarterback,
Hmm.
then it's actually gonna ask me to identify which one of the Lamar Jacksons I would like. So this is fully conversational, which is really awesome. So if I say the Baltimore quarterback, now it's actually going to go in and now it can sort of proceed in doing that lookup for us.
Gotcha. That is cool. This conversation. So it's not anything too. Like I want to clarify. It's not a code that you guys have to use or a certain way you have to input these questions. You can just type plain English and it'll generate all of this.
Yep, exactly.
All right. So we've clarified Baltimore quarterback. What's it spitting out here? What is all of this?
Yeah, so it's going to give a summary of the plays that it's bringing back. It's going to give us a few highlights of some of the standout plays, and then it's going to sort of do another like little bit of summary wrap up here, and then we're going to go down here and we can see all of the plays that it found. So it found 3 plays.
Okay. And
Um,
to be clear too, it just so is it automatically just searching for the current season, or do you have to specify year? Like what's that? How's that work?
That's a great question. So the way that we built this, if you don't specify a season at all, it's going to assume that you're asking about this current season.
Gotcha.
If we wanted to, we could ask a question and say, we could ask the exact same question and say in 2022 or in 2017.
Yeah.
We're able to go back all the way to 2017 and get answers from Next Gen Stats.
Perfect. That was my next. You stole it right out of my mouth. I was going to ask how far back can we search here? So this is for 2024. It looks like there's been 3 examples of it so far.
Yep. So I'll show you the links to the media in a second here, but I think one cool thing to sort of call out is I can hit this info button on the API call info, and I can actually take a look at the all the reasoning that we went through in order to get to the API call that it made to Next Gen Stats in order to get these results.
Okay.
So it's just super cool. It's a great way that like if I'm pretty dialed into NGS and how the API works, I can take a look at this and sort of confirm in my head that yeah, this is doing exactly what I would expect it to do.
Okay. So you can
So
check its work basically.
yeah,
Verify that
exactly.
it's pulling the right steps. I think that was one of the comments from users here. Is there a problem with hallucinating? Like, do we have to verify all the different results every time? And it looks like you guys accounted for that.
Yeah, we've kind of done that as much as we can. So I'm going to start here with the with Media Portal. So Media Portal is our asset management system. So that's where we have our million assets housed. So if I click this link, it's going to take me into that asset management system, and it's going to give me automatically. So I was saying before where we used to have to type in that game key play ID every time that we wanted to search for one of these plays that came up in the search results.
Mhm.
Now we automatically go directly to a search that's already been built for us based on that specific play. In this case, this first clip is
Can we zoom in on this a little bit too? Looks like
yeah,
just want to
sure.
make sure our audience can see this well. There we
Okay.
go. Yeah, that's
All
perfect.
right. So if I take a look at this is a melt of all the angles of the play from the broadcast. So I can go in here and got a nice slow-mo shot of this play,
Perfect.
right? So that's cool.
Yeah.
Um, lots of different angles. Depending on what kind of play it is, depends on the number of angles that we actually have. A touchdown, we're gonna have a lot more angles than you know, a, a a run for a 1 yard loss or something like that, right?
Gotcha.
And then the second clip is a clip from NFL Films. So this is sort of like the that film footage that everybody's used to seeing in lots of documentaries.
Gotcha. So we've got a question coming in here. How do y'all process the videos for the AI to understand it? Is there something you have to do? Is there somebody sitting in backstage, like inputting what each happens in each of these plays, or how does that work?
Yeah, so we have a pretty robust set of metadata that we pull in for all of the footage that we have for games. So this footage that we get from films, we actually get a metadata sidecar when they deliver it to us, and that gets ingested into our system. And so there's no AI to this piece of it. It just has, if I scroll down here, it's got that game key and the play ID. So that's what's allowing us to actually do that search
Gotcha.
for this footage.
Okay, cool. Yeah,
Um,
V78. There you go.
Yeah. And so if I come back here and we just look at this other the NGS media links, so this is where we're going to get up to 4 angles per play that comes back. That this is outside of our asset management system. This is going to be though the broadcast feed that you're used to watching at home, and then the all 22 angle, and then also the 2 end zone cameras. So if I go to that all 22 that everybody loves, you can see that this is the entire play, and it's just that one single play.
Gotcha. So the tool basically, again, just to summarize, plain English, you input, this is what the play I want to see, or the play type I want to see.
Yep.
It spits out not only every single clip from every single camera angle available, whether that be the all 22, whether that be NFL films, whether that be standard broadcast, gives you all the options, gives you a summary of all those options, gives you a summary of the stats, and like kind of writes up a little paragraph for you summarizing everything that happens in between.
Yep,
So
exactly.
it's your one-stop shop for your team, basically.
Yeah.
Gotcha. So got some shout outs here. Troy AWS says loves seeing this demo. So that's pretty cool. And then we got a question related to the Giants, which I think is a good use case. So does the system only allow for individual play types, or could you do something like, hey, can you show me full drives? Like, so like Eli Manning game winning drives, or like, what's the capability? How far does it extend?
Sure. So currently, based on how this is built, we're doing searches that are based on specific plays. So
Okay.
you can't actually do like a drive, and you would have to say, like ultimately you would be asking about like the touchdown, or you could ask about like situations in which they got a field goal or something like that.
Gotcha. So you could type in like game winning touchdown, but you couldn't type in like game winning drive, or like touchdown in the last 1 minute or something like that.
Yeah, and some constraints to what it's able to handle.
Okay.
But that's one of those scenarios where I think we're always looking at like what's next for the tool. And I think one of those things that's next is to be able to expand its capabilities beyond just being able to answer questions about specific plays.
Gotcha. So let's do another example. So in honor of our friend Jugor Jugord Jam 12, I know I just butchered that, but he was the Giants, or or she was the Giants fan that asked about Eli Manning touchdown drive. Since we can only do certain plays, let's do another Giants play inspired by them. So what about let's do current Giants. Let's do Daniel Jones passes of more than 25 yards in 2022. Let's specify a year other than 2024.
Passes more than how many yards did you say? 25?
25 yards in like 2022 regular season, say. Do you have to specify regular season versus postseason?
That's also a great question. So by design, we've designed it so that if you don't ask, then it's assuming regular season.
Oh, okay.
If you want to add regular season like I did, then obviously that's going to do regular season. But you could also say postseason, or you could say regular season plus postseason. You're going to get answers no matter what.
Gotcha. Okay. That's pretty cool. And it's crazy how fast this is. Oh, we got another question. Is there a public version of this tool? I mean, I would love one for my fantasy football team. I'm sure other people would too. Or is this currently just internal for you guys?
This is currently an internal tool, but it's definitely one of those things where I think we're looking at ways that we could you know, incorporate this somehow in the future.
Gotcha. Well, cue Ruxy. You and I will be sitting on the edge of our seats waiting for that public tool. Well, let's see. It looks like there was a lot more than I thought here for Daniel Jones passes of that long. So, how many
Yeah.
results did it have there?
We ended up with 15 results.
Wow. Way to be, DJ. Danny Dimes over
Yeah.
here.
So again, we go to that all 22 angle.
Okay.
There you go.
That's pretty cool.
2022, pretty good year for Danny Dimes, huh?
Yeah, I guess so. That was when they won that one playoff game, right?
Yeah.
Didn't he break the record for most rushing yards by a quarterback or something in the playoffs? There was some amazing game he had in the playoffs that year, I think. But I mean, what before we leave here, I mean, love this demo. Looks like the audience is loving it too. What's your favorite feature? What's the one that you like using the most as you're playing around in this tool?
I think the thing that I love the most is actually what we're going to talk about in the second half here, which is the ability for us to take a good response that we really like and to commit that to memory.
Gotcha. I think that was a perfect transition, Eric. It's almost like we kind of practiced that. So with that, love this demo. Let's get into a little bit more about how it actually works. And I, guys, am not the best person to discuss the ins and outs under the hood of how this tool works. So for that, let's bring in our other three hosts here from the Normal Data Dive Show. We've got Jason Hunter. He's a principal solutions architect and the Normal Data Dive host for you guys. Ross Clater, the principal applied scientist, and Sanjit Misra, senior technical PM for MemoryDB. Guys, can you quick introduce yourselves?
That was great, Nick. Yeah, I'm Jason. Usually I start at the top of the hour, but this time, Nick, you're a football fan. You wanted to have the first half hour to yourself. So I'll be doing the figuring out what happens between when you type the text and you get the video with these other two folks who actually know the tech better than anyone.
Awesome. Ross and Sanjit, you guys, like Jason just said, you guys are the tech guys, right? You really know how the back end of how this tool works, right?
That's right. So hi, everyone. My name's Ross. I'm a principal applied scientist with professional services, and I was the tech lead on this project. It was really fun to work on.
Hi, everyone. I'm Sanjay. I'm a senior technical PM on MemoryDB, one of our in-memory database offerings, and I helped to launch the functionality for MemoryDB, vector search for MemoryDB that helps to power this tool.
Perfect. So, guys, I think I'm going to peace out. But before I do, everybody remember to take the survey. Let us know what you like about the show, what you don't like about the show. It literally is only 3 questions. I am not exaggerating. And I think the first 200 people, hopefully my producers don't yell at me for misquoting that, but I think it's 200 people take the survey, get $20 in AWS credits to try out some of this stuff yourself. Maybe make your own database, trash talk your friends for your own team. But guys, Eric, thank you so much for talking to me. Jason and team, thank you so much for letting me guest host. I'm going to go try to use this tool backstage here to help, like I said, my fantasy football team. But thank you guys so much for having me on the show, and I'll let you take it from here.
All right. I appreciate this opportunity to really dive into what goes on because it seems a bit magical. As a kid, I did actually wonder, how do they make those highlight reels? And I thought that there was somebody who just knew everything. I figured you go to that person, they're paid a lot of money, and you say, this is what I need. And that person says, all right, go to this game in this quarter and you'll be able to find it. But that's not what it is. There's computers doing it, not some really smart person. I guess that's a question for Ross.
Yeah, so someone's got to be providing all of this metadata tagging underneath. And that was actually a wholly separate project. So I can't really even speak to that. I think that's part of the larger Next Gen Stats initiative. But there is some mechanism in place that is making all these metadata tags to the plays to say what the formations are and what the yardage is. And that feels like something of a magical process to me. I think that may be a good topic for another Twitch session.
Yeah. How do we get to this? But assuming that we have a library of all this data, then my next guess would have been, and I know I'm wrong, but I would have thought all right, you put it into a search engine and you load all this stuff. And then it's just like you go to open search and you say, give me this. But that's not what it does either.
Yeah, I think what we saw is the way that we're fetching this information is by making a very specific API call. And part of the kind of the blessing and the curse of the fact that we have so much metadata associated with these media assets is that it becomes tricky to search. And there's lots of different ways that you could apply metadata filtering to it. And so the way that we're collecting it is by formulating an API call and then executing that API call against the next-gen stats source system and bringing back the results associated.
So the job of the LLM, we have an LLM in here, is that you type what you want and an LLM bridges between your expressed desire and some single or multiple backend API calls to pull the data. So it doesn't generate text, it generates API calls.
That's right. So it's a little bit more complicated than that, the workflow, but the general idea is exactly what you've described. We want to take the user's intent. We want to convert that into an API call that can be executed against our next-gen stats backend, execute that API call, and then bring the results back to the user.
All right. So it's like you specify a task or an intent or something, and the result is an action or a plan, something like that.
Sure. So I think a plan and execute is a really good way to think about it, where we have the request that comes in and it's find me all the times that Tyreek Hill had a touchdown longer than 60 yards or whatever your request may be. And the system needs to generate a plan. And in this case, that plan is what API call can I use to collect the information that I'm being asked to collect. And so when it creates this plan, it's formulating an API call based on the specific attributes of the next-gen stats API. And then when it goes to execute on that plan, it's going to make that API call and return the result. So I think a plan and execute is a really good way to think about it.
All right, so plan and execute. So kind of like a wedding planner where I say, I want this, and I express it in text, and the wedding planner knows how to make the right calls to a florist and a chapel and a photographer to get what I want. It's not a search engine where you find whoop, here it is. You do some sort of series of things to generate the result. Is that a simplified way to think of it?
Sure. Yeah. And I think if just trying to take your wedding planner analogy, just maybe one step further is you wouldn't say, hey, wedding planner, plan me a wedding. You might say hey, here's a plan. Here's a wedding that's similar to the one that I would like to have planned. So maybe use this as a reference to when you're going about creating your plan for my wedding.
Okay. So you take the text and you go to an LLM and you say, I need a plan for this, set of API calls, the right workflow. You figure out how to get the data. And you're saying that if it only did that, it wouldn't be as good as if you can provide a historic sample that was good.
That's right. Yeah. So
kind of like this.
I think generally speaking with language models, it's safe to say that if you're asking them to perform a specific task, then you're going to have better luck getting the result that you want if you provide examples. And so this is this concept of in-context learning, or maybe few shot prompting, single shot prompting. You'll hear these terms thrown around, but the general idea is that you don't just want to ask a language model to complete a task and keep it open-ended. If you can provide it with a sample of what you would like to accomplish, then that's going to help focus your language model and help you improve and get better consistency around the results.
Well, that makes sense, because it's just like when your boss says do something and they can give you an example of it being done last year. I need the 2024 plan. Could you show me the 2023 plan so that I can see what a plan looks like? I'll do a better job with the 2024 or 2025 plan.
That's right.
But there's a chicken and egg problem, because you just asked the LLM to do a thing and you have to show it a successful example for it to do it. But how do I bootstrap this? How do I, you know what I mean? How do I generate the thing that I have to show the generator?
Sure. And so the way that we're creating these examples is by taking advantage of MemoryDB for Redis. And it's this concept of semantic caching, or it's just a traditional RAG workflow, really, where the request comes in and we're going to search our vector database, MemoryDB in this case. And we're going to say, hey, what have I done in the past that's similar to what I'm being asked to do now? And let me find the nearest match to that and pull back the metadata associated. And the metadata associated is, let's say, for example, my ask is, how many touchdowns did Brock Purdy throw in the fourth quarter? And the nearest match I have is, how many touchdowns did Tom Brady throw in the second quarter? Then that's a pretty clear match. And I can use the API call that I use to complete the second task as a reference to generate the API call for the first. And I think to try to answer your question is you do have to bootstrap it a little bit. So the database accumulates as we use it and as we add more memories to it. But you do have to kind of bootstrap it with some with just a handful of starting examples just to kind of kick it off and give it an idea of what you're talking about.
Okay, this is getting interesting. So Sanjeev, what is MemoryDB that we're using here?
Yeah, so MemoryDB is AWS's fastest, fully managed database that provides that in-memory performance. So really, MemoryDB is one of our in-memory database offerings, like Elasticache and MemoryDB. MemoryDB really uses really kind of provides that 11 nines of durability. So through kind of a multi-AZ transaction log that enables this. As Ross kind of noted, it is compatible with open source Redis with plans to incorporate Valkey as well, which is an open source fork of Redis sponsored by the Linux Foundation. So it kind of provides that ultra fast performance that the fastest performance of any database offering in AWS.
One of its distinctive features is that it has a vector index, right?
Yeah, exactly. So in July at the New York Summit, we actually launched vector search functionality for MemoryDB in GA. So it does provide the fastest vector search performance at the highest levels of recall amongst popular vector databases on AWS. So what that means really in practicality, it really provides that single digit millisecond vector query and update latency alongside a lot of traditional vector database capabilities that you would really imagine, like pre-filtering, vector storage, indexing, updates, search, and all that good stuff with integrations into common frameworks that a lot of folks use for their generative AI applications like LangChain as well to really help you get started.
Can you give me a 30-second explanation of what a vector index does or a vector search does?
Yeah, so as Ross kind of noted, when you provide these vector search functionality, it really means that you're providing the ability to store a semantic representation of text in a vector format. Think about your traditional kind of XYZ vectors, but in multi-dimensional space, so like up to like thousands of dimensions. And what that really enables is that when you kind of run these searches, these semantic searches, you're able to search and provide and identify kind of texts that are semantically similar to what you're searching. So in the context of the NFL, it could be questions, as we were noting earlier, like how many touchdowns did Brock Purdy throw or what have you, and being able to represent that into a vector space so that when questions that are very similar in nature that have the same meaning are asked, you're able to pull back information relative to any of the prior searches that were semantically similar. So an example of like a few use cases where speed really matters, like a lot of our customers are using, are, like an ads organization that, as you're asking, they have like millions of products in the catalog, for instance. Mm-hmm. And as you're asking questions or you're asking about specific types of products, there might be different ways to kind of specify those products. So you might ask about a jar or a container, which might be very semantically similar. So when you ask about like jars are available on this website, you're able to return back all the types of products that are semantically similar. So you're able to return, like this ads organization is able to return back, thousands of products that are very similar in what you're asking within that single digit millisecond latency. So, as a user, you're asking those questions, you're able to get it ultra fast right back to you so that there is no wait time. It's within that single digit millisecond latency.
And here's how I think of it. Let me tell you how I think of it, and you tell me if I'm right. Yeah. Classic MemoryDB. I give you a key, you give me the value. All right. It's like a hash table, but in memory and fast and durable. But now I can give you a key and say, find me whatever is closest semantically to my key. Might not be my key, but is semantically similar using a vector index on the back end. And it's a key value lookup without an exact match required on the key. It's an approximate match on the key. Yeah?
Yeah, exactly.
Right.
Yeah, exactly.
That's cool. So then, Ross, when you're doing this work, you take the text that Eric types and you need to hand it to an LLM, but you're using MemoryDB's feature here somehow to go, here's the text the user wanted. Do I have a previous query in there that might not be exactly this, but kind of like this? Is that the idea?
That's right. And so it comes back to providing the language model an example. And providing the language model an example is good, but what's better than that is to provide a language model with the most relevant example we can. And the way we do that is we search for the most similar request that we've completed successfully in the past and pull back the API call. And Eric showed us we have not only the API call, but also the reasoning associated with it. So we could say, hey, here is a request that you've completed in the past. Here's the API call that you use, and here's the reasoning behind that. Like, here's what your thought process was. Now use this as a reference to generate an API call for this new request that we're giving you now.
Wow. So every day this app gets better because it's remembering previous successes and reusing them.
That's right. So I like the term experience accumulation. So just as we're accumulating these experiences, the space of unknown requests just gets smaller and smaller.
All right. Now, I have two follow-up questions. One is, all right, so you got like Dolphins and Chargers. How does an embedding model know that those are relevant? Because they seem like Buccaneers and Raiders, like, all right, those are
Sure.
similar, but sometimes things maybe aren't.
Sure.
And so how do you handle that?
Yeah, and that's a great point because they don't, right? So like these general purpose embedding models are not context aware. So they don't know that we're talking about the National Football League. They don't know that how many touchdowns did Brock Purdy throw against the Dolphins is effectively equivalent to how many touchdowns did Tom Brady throw against the Chiefs. And so one way you can address that with embedding models is by training a custom embedding model. And the way you go about that is you take a whole bunch of pairs of text and you say, hey, these two sentences are effectively equivalent. And you tune that embedding model to start recognizing those types of patterns. And it's because these embedding models lack context. We've gone about this a little bit differently. Instead of tuning a custom embedding model, what we've done is sort of, what is the word? Redacted effectively the text prior to passing it into the language model, or passing it into the embedding model. So let me tell you an example. So if we had a request that comes in that says, how many touchdowns did Brock Purdy throw against the Patriots? What we're going to do is before we pass it to the embedding model, we're going to replace any reference to a specific player with just player, and any reference to a specific team with just team. And so that way there's no distance between similar queries if really the only difference is the player and the team. And that's useful for our embedding space because from our perspective, those two requests are effectively the same.
Right. So as far as making an API call, it's just a variable substitution. So you want the vector distance between two questions that just vary by player or team to be 0 in vector space,
right.
Not relying on an embedding model to be like, well, they're the NFL teams are so big that probably an embedding model knows that these words might be related, but not as well as team. It's almost like dollar team, dollar player.
That's right. Yeah, that's the idea.
Now,
Is make sure we're getting the best matches we can.
How do you know that you're not learning off junk? How do you know that you didn't remember a previous request and the previous request was awful and now you just keep forwarding the awful time after time?
Sure. Yeah. So we can choose when we want to commit to memory, right? And the way that we've set this up is we've introduced an approval gate effectively. So within the application, there's a concept of an admin, and I think Eric can maybe hop back into the application and show us this. But as a user, I don't have the ability to submit a task to memory. As an admin like Eric, what Eric can do is he can come in and say, hey, show me all of the requests in response that I've received over X amount of time. And then Eric, as the admin, can review them and say, okay, here's the API call that was made. Here's the reasoning. And if he approves, then he can check it like he is now and then click save. And what that's doing then is that's writing it back to our MemoryDB instance. It's writing it back to memory. I like to think of this as long-term memory. And so that the next time we get a request that's similar to what we've just saved, we can retrieve it.
That keeps the garbage from going into the memory. The admin blesses it. So over time, people ask real questions. The admin goes in and says, that was good. I like how this went. And now you've got more guideposts out there until at some point you're almost always retrieving something that is known good, and you reduce any chance of, I don't know, is it hallucinations we're preventing? Is it just, what are we preventing there? We're definitely learning.
Yep. So there's two ways to think about it. I think one is preventing hallucinations because we want to narrow the focus of what we're asking our language model to do. But there's another benefit of this. If we make a request that is not similar to anything that the system has completed before, then we want it to think about that a little bit harder. So we want it to go actually read the documentation for the API and say, hey, what features do I have available to me that I might be able to use to collect this information? And let me kind of think about this a little bit harder. On the other end of that spectrum, if we are asked a new request that we've already done before, we know what features we need for touchdown passes in the fourth quarter. We don't need to read the documentation. We can route the traffic differently in our workflow based on whether or not we've completed a similar task before. And as we add more tasks into the long-term memory, that space of unknown tasks becomes smaller and smaller. More and more of the requests will get routed to that fast route. And so as you're using the application, it becomes faster and cheaper just from using it.
It's pretty wild. Why did you pick MemoryDB for this?
Sure. So I actually really love MemoryDB for this. So there's a lot of vector database solutions out there, and the messaging that you get is use the database that you're already using, right? And so we have a web application, and within that web application, we need to maintain state. And so this is, if we use long-term memory to think about our semantic search, we can think about state as maybe the short-term memory. So it's the conversation history. So when Eric asks a follow-up question, it understands what that context is. And MemoryDB, Redis in general, is just really good for managing state within a web app. And so one thing that I really like about MemoryDB is that it serves as one data store for both our short-term memory, our session management, and also our long-term memory, which is this semantic search. So we don't have one database that we're using to keep track of our vectors and another one that we're using to keep track of our state.
Gotcha. We're getting some questions about MemoryDB and people trying to understand what it is, and is there a version of MemoryDB that is not using open source Redis? That's for you, Sajid.
So right now, MemoryDB is built on top of open source Redis. We do plan on releasing functionality that's also compatible with Valkey, which is the open source fork, the fork of open source Redis sponsored by the Linux Foundation. That will come out soon.
Gotcha. All right. So what we're seeing here, I don't know, I haven't seen this before. The idea that I use the semantic caching to then feed an LLM input is within context. It's like semantic caching within context learning. But then do other people just use the cached result and not try to feed it forward? Is that kind of, I think that was RAG. That's what we usually talk about with RAG, right? You want to tell me about RAG?
Sure, I can take this one. So
Okay.
if we think about retrieving what I've done in the past and returning that context, then it's sort of up to you as the developer what you want to do with that context. So you can imagine a scenario where it's more of a question and answer type of a workflow, and you want to be able to search for the answers that you've already provided to similar questions so that you don't have to go back to your knowledge base and ask it again and again and again each time you get it.
Right.
You already know how to answer that question, so you can just give the answer right back and just provide that context straight back to the user. We've implemented this a little bit differently to where we're not providing the context back to the user. If we kind of go back to your analogy about the wedding planner, the way we're thinking about this is that we're not necessarily saving the results of that API call. We're saving the plan. And so that way, when we need to make a plan for a similar task, we can use the plan that we had created previously as a guide.
Right. And then someone asked, Q Ruxy, can MemoryDB be used for RAG workloads with large PDFs using OCR, which is, the classic use case of semantic caching, right?
Yeah, sure. So it can certainly be used for any type of a RAG implementation. I would venture, and maybe Sanjay, you can speak more to this. The type of vectors that we're talking about here are relatively few, right? We're storing long-term memory. So we have maybe a few thousand vectors that we're going to wind up storing in this database over time. And that's great because we're going to keep it all in memory. And that's why it's so fast. If we have a ton of documents that we want to chunk up and create vectors and do a more traditional question and answer RAG, then maybe MemoryDB isn't the best solution. Maybe we have a better option. I don't know, Sanjit, if you have any comment on that.
Yeah, so MemoryDB can store tens of millions of vectors up to thousands of dimensions. So it can support those larger use cases. Just depends on your actual workload size. So kind of just we'd have to go through that, but there's a vector calculator actually available on the console within MemoryDB to help you size your workload appropriately.
That's cool. Any other customer stories that you want to tell us about, Sanjeet?
So I think Ross kind of went through a great like semantic caching use case with the NFL. However, there are other types of use cases here where a lot of our customers are using semantic caching to really cost optimize and also for performance improvement. So like a type of use case that one of our organizations, one of our financial services organizations are using it for is essentially they have a large corpus of data around, their ETFs, around crypto and other types of pieces of information where a lot of their users are actually asking the same types of questions about specific types of ETFs, types of, questions about Ethereum or what have you. And oftentimes what they were seeing was they were asking those LLMs like pretty much continuously and answers those questions over and over and over. And first thing they saw was that their costs were getting extremely prohibitive because obviously those calls to those large language models are extremely expensive. And then second, those large language models are very slow. So it takes seconds to respond. And they saw a lot of their the price estimates going up significantly year, like projected for the next year. They also saw that type of response was very slow. So what they did was actually use MemoryDB as a semantic cache to store off the answers associated to questions that were asked of the LLM so that in subsequent types of questions that were very semantically similar, they were able to basically go to MemoryDB directly, provide the answer back, and avoid hitting that large language model again, which basically meant that they were able to return answers back to the user within single-digit milliseconds versus single-digit seconds. And they were also able to save a ton of money because a lot of these questions were the same types of variations of the prior questions by other users. So it was kind of, dramatically drop their cost and dramatically improve their user experience. So
in the NFL's case, they always go to the LLM to refine, make sure they get the perfect API. Right here, it's like a fact. You go to a documentation page, type your question. It says, oh, someone typed that question before. Here you go. And there's only 1,000 questions people ever ask about a thing. So you kind of pre-cached it. And the LLM can stay quiet most of the time. And you get really fast answers. I like it. Right.
Yeah, exactly.
We're almost out of time. I do want to say thank you, Eric. That was really cool. And I bet everybody wishes they had access to that URL. So I'm sure that's the feedback. That was really cool. And I think it was pretty interesting for me, Ross, what you did with the learning, right? I mean, it'd be one thing to say, here's the question, make me an API call, but to provide that example of previously blessed good examples to make it better and better is something I hadn't seen before. So I appreciate that. Are there blogs people can read? If someone wants to know more, what should they go read?
So
sorry. Sanjeev, you got it.
I know there were a few that are specific to MemoryDB that maybe we can throw up.
Okay, so we can put into the chat some links to blogs because I think this was written up, right?
Yeah. So some of the blogs are actually already posted in the comments around using MemoryDB for vector search and also the semantic caching blog that we also wrote. So that really kind of help you get started, like some Terraform scripts to really help you deploy this against knowledge bases and MemoryDB. So it'll be a kind of quick start for a lot of folks.
And there is a publication forthcoming. There's a publication forthcoming for this project specifically. It just hasn't been posted yet. We're expecting that soon.
Oh, awesome. And then in 20 seconds, Sanjeev, what's the difference between Elasticache and MemoryDB? Someone asked. You have 20 seconds left.
MemoryDB is really kind of our it provides kind of that full the 11 nines of durability. So no kind of risk of data loss through kind of a distributed multi-AZ transaction log. So really provides you that certainty, that durability, and MemoryDB is a true database. So that's why I noted earlier, is kind of our fastest fully managed database, provided that in-memory performance at AWS.
Total durability, because Ross does not want to lose what he remembered and worked so hard to build. So he puts it in MemoryDB. It's safe, it's fast, it's vector. That's the takeaway. All right, thank you. We're out of time. I really appreciate it, Eric. That was great. Thank you, Ross. Thank you, Sanjeev. And thank you to Nick, wherever you are.
Thanks, everyone. Take care. you.